Okay. So, yeah, I'm just in my DPL Fall 21 folder. I'm going to make a directory week 5. CD into that. I'm going to make another directory called classes. CD into classes. And then I'm going to touch, let's call this person, or lowercase person dot RB. Just going to make a Ruby file here and then open this up in code. So object-oriented programming is it's really popular because it's a good like mental framework that like really represents the real world. So it's one of those ways we can take something like code that can be confusing, because code really is, coding's really all about like abstractions and like abstracting complex like things into things we understand as people. So someone came up with object-oriented programming just as an abstraction to make coding simpler. So has anyone done like any machine language coding? Yeah. Because when you talk about code, you have something like Ruby. You have a language like Ruby. And Ruby's nice and readable. That might, I don't know what Ruby compiles down to. Ruby might compile down into something like C. And C is like a more lower level language where you're kind of closer to the like hardware. And then C is going to compile down into, yeah, like assembly code, which is going to be really, really nasty looking. It's like you're coding with like memory addresses. Like here's a memory address pointing to like the function. Yeah, it gets really messy. And then that goes to machine code, which is really, really messy because that's just your zeros and ones. So we have all these abstractions, and then we even have something like Ruby on Rails, which uses Ruby. So it's all about making something that converts down to zeros and ones more readable. So that object-oriented languages are just a way to make something like C a little more usable. So if we're thinking about like the real world and we want to create a object in Ruby, we're going to use this class keyword. And then I'm going to give it the name of the class. We've seen this with models. And then I do an end. I've now defined a person class. And now I can create an instance of a person. With this person.new. And I can put p.class. So I can now run this. Remember how we run this? We just run Ruby and then the name of the file. So I'm just putting out the class of my person, and that is a person. So this is how we can kind of define our own types of data with classes. Now think about the class right here. I consider this is like our blueprint for a person. This is the nice thing about object-oriented programming. It allows us to create these blueprints for like these objects in the world, for example, like a person. And then we can create instances of people. So now I have two people, they're a class person. Now a person, should have like a name and an age, right? All people have a name and an age. So we can have our blueprint handle this. We can come in here and we can create this initialize function. Now this does have to be called initialize. I'm just going to log this right here, puts initialized called. So when I call the new method, it's going to call this initialize method. And this is how I can pass this some data, because a person should have a name. So this is going to take some parameters now. This is just a function and an age. See, now if I run this, I get an error. I'm calling person.new, and it's saying, hey, I expect 2 arguments. So let's go ahead in here, and now I can actually pass some values for these instances. And here I can create some instance variables for this class. I can create functions on this person. Let's do puts here. At age. So now I can have these instance variables, and then I can have each person, I can define like this say hello method that each person has. But they're gonna, depending on what their name and age is, it's gonna be different. So now I can do like puts John.say hello. And Jill.say hello. I don't need to put that. Let's actually just have this return that string. So I'm putsing it out right here. So if I try to call, like, let's say I want to call Jill.age. I get an undefined method age for Jill. Now, there is a instance variable on Jill called age, but it's right now it's what's called encapsulated. It's encapsulated in this class, so I don't have access to it. In the blueprint, in the class, it does have access, but I can't call .age on Jill unless say an undefined method age, I can come up here and I could, I could come define a method age, def age, and just return age. I can now define that method and return it. But another thing, since this is a very common thing, this would be referred to as like a getter, a way to get the age. I also need a way to set the age. So there's actually a shorthand in Ruby. I'm gonna get rid of those. There's a shorthand to do the getters and setters. It's called the ATR accessor. And then I can say what I want to be visible. Name and age. So now I can assign, I can change these values with that. Maybe I don't want someone to be able to change like the age. I just want to be able to read it. I can use the AT attribute reader. I have a syntax there somewhere. Oh, I have a comma right there. And now this fails because now without that being a accessor, that means I can't write the value. I can only read it. So now someone in my program using my person class cannot change the age. Because I might want to protect that, because maybe what I want to do is maybe I can, give them a birthday function. They can only change their age by, this function. Age equals age plus 1. Because, yeah, Jill's 34. There's like no way someone can like go back in time and like change their age. So I might want to like encapsulate that and kind of protect that so coders can't change it like that. But they could change it in a way where they could have like Jill have a birthday. And then that would change the age. Questions on that? Let's just do another example just to kind of show what we could do. So for instance, we could have a dog class. Just write another one, class dog. And like, let's say, I'm just going to write these as getters and setters. Does that make sense, the getter and setter? Where else have we kind of seen this term? Or where else have I used it?
Use state.
Yeah, use state. This is kind of like a coding. It's a way to get the value and to set the value. You could also say this as like a way to read the value and a way to write the value. You'll hear those terms. read and write. Get and set are kind of similar. So an A attribute accessor, that gives us both the set and write capabilities. So we're going to create some instance variables for this called name and breed. So all dogs have a name and breed. And do def initialize name breed. Create these instance variables. At name equals the name that was given to us with this function. And at breed equals the param breed. Okay. So we have these two terms. I briefly talked about this, but we have this should maybe make a little more sense now that we're talking about instances of classes and just the class itself. So we could have instance methods. This is methods called on the instance of the class. So def info. Yeah, we could just do like turn the string like name is a breed. And interpolate the breed. And then we could have a class method. I'm just going to call this the same thing, class info. And this can put like, I am a canine. That's not how you spell it, right? Canine. Canine. Okay. So well, let's see what this, oh, sorry, it's not class, it's self. Let's see what this self keyword does. So I have two methods called info, but one has this self keyword in front of it. This is a class method. And it is called on the class. So let's see what that means. Let's do a demo. So let's come in and create a dog or a couple dogs. Dog.new. Lab, and then
I'm sorry, what does the self do?
the self is going to make this a class method. Starts with self. Yeah, we'll look at this in a second here. So just create a couple dogs. Oh, red healer. Okay. So I can put out Lars.info. I can put out Willer.info. Let's just run these two. Talk about instance methods first. Oh, I need to run my dog file. Dog.rb. Oh, spell the name there, right? But you can see these methods are called on the instance of the class. So you think the class is the blueprint, and then from that you can create instances of that class, actual things. And they can both have these methods, info. Lars info, well, Lars is a breed lab, Willard is a breed red healer. But then there's the class method that's called on the class, puts dog.info. I am a canine. And actually I probably even shouldn't use I, because I would refer to an individual. Like, this should be more like dogs are. Because it's kind of like a class method would refer to like like what's specific to the whole class. Like every dog is going to be a canine. I could just have that, return canine. What is that? Is that the species? Could maybe just call that method species instead. So instance method, they're going to have like deal with like a specific individual of the class, an instance of it, where the class method would refer to something that's going to be the whole class. Does that make sense? So, and we've seen the new method before, right? In our create function where we create a new instance. So that's what we're doing when we call the new method. We're just creating a new instance of our model. And we're just not saving it to the database. The create method would create a new instance of it and try to save it to the database. Let's also look at the private methods and what that is all about. I'm just going to go back to like my person class. And we've seen the private keyword. This is where we can define, private methods. Secret phrase or something, I don't know. Let's just call it secret. I'm going to just define a function called secret. So this is now I have a method in my class that is a private method. And so if I try to log like jill.secret, on my person file. So it's saying right here, private method secret called for, person. Does anyone know what this is right here? That weird looking number, 0-007 FB.
Is that a timestamp?
It is not a timestamp. It's the memory address. So when we say it's creating this in memory, well, there's the address right there of that object. So yeah, there's machine language for you right there. It just look like a whole bunch of those addresses. Yeah, so it knows about the secret method, but it can't call it because it's saying it's private. So you cannot, that's the whole point of making this private. It's like, well, now you can't call this method on a instance of it, but you can still use it within your class. Like you could say something like def, because maybe there's like a secret that gets like a secret thing, but then you want to like return like a, I don't know, something that's not secret, like a public key that you need the secret to use. So you could say like private key equals, and then use your function that grabs like your private key, and then you can say something like return vector private key, whatever. We're not going to do like a hash function or anything. Like I need to use this private key for some weird math thing to get the public key. So then we could do jill.public key. Cool. So I don't know. I don't know what the secret is, but I can still use it in my class. I can use this function that might grab something that I don't want exposed to any developer. Okay. There's also something called a module. Let's just do that really quick. We're not really going to use any, but just to show you, there's a module is like a class, but it's not like a class. It's more like, let's say you have a whole bunch of like functionality that you want to share across files. Like for example, some math stuff. You can come in and make a math module. Like, you know, you're going to have like this add function that you're going to want to use all throughout different files of your app. You can create like this module. And, you know, we might have like a minus function. And then in my person class, I can go ahead and I can include that module. And then for whatever reason, maybe I want to add inside of here. Then I can use that function. So it's just a way we can, I probably have to require this. Let's see if this fails. Let's go in here and say require math. Oh, what did I call it? Oh, I called it module. That's not a good name for that. Math. I want to call that math.rb, just the name of the module. Let's require that. Oh, sorry, it's require relative. What am I doing? Require relative. This is how I can import files into other files in Ruby. You know, in JavaScript, it's import. With Ruby, it's require relative. The require relative, that just essentially takes this file right here and just plops it right there. And we've also seen the require keyword. This is like if it's in, like if it's something you've installed with like a gem. Like Faker, we use, it's a gem. If it's a file, you're going to want to use this require relative. So if you have a lot of, complicated logic that you're going to reuse throughout files, you can create a module, and then you could reuse that in your different classes or different files. Okay, let's talk about one other thing with classes. So this is, like I said, this is a really brief introduction into classes and object-oriented programming. But we're kind of hitting some of the like basics of encapsulation, which is like hiding stuff from users. We're also, the next thing we're going to talk about is inheritance. And you already know what this concept is. It's just like inheriting something from your parents. So let's come in here and just do that. Let's do like a parent model. And let's do a child class, not a model, child class. So I'm going to create a parent and a child class. I'm just going to come here. I'm going to define this function called use parent method, which is this method right here. And I'm just going to log this. Just do a puts right here. Puts called from parent class. And then I'm going to go to my child class. And I can have this class child. And this is, I'm going to read this as like extends or inherit froms. I'm going to say extends because that's the word I'm used to with Java and JavaScript. But what this is saying, I'm going to have my child extend or inherit from parent. So now my child is inheriting from parent. So then I can come create a new parent. Let's do p equals parents dot new. Okay, and c equals child dot new. And then I'm going to call the use parent method on both of these. So this is in my child class. Let's run that. Ruby child.rb. But yeah, I need to require relative parents. So my child doesn't have that use parent method, but since it's inheriting from parent, it has it. So that's inheritance. We can have I'm just gonna call that yo, just so this override has no special meaning. I can come in here and define another function. So I can override functions. So let's call this from parent. So if my parent defines a function and then my child defines it as well, well, the child method is going to override it. So override yo called from the parent, and override yo called from the child. So you can define the same function in your child component and it will override the parent one. There's, let's call this alterable. this one's a little, so a child can call a method from the parent and then do its own thing. So we can define this function alterable. So I can call the parent method with super. So this super keyword, it's saying, hey, call the parent alterable method, but then I can do what I want. And then let's call these. So they both called that alterable called by parent. So they both call that, but then the child can do some additional stuff. Questions on that? It's more just like a little demo. I'm just going to slack this one out and let's just look at it. So let's look at kind of like a semi real world example with inheritance. So let me select this out. I'm just going to call this mammal. That's not how you spell mammal, but whatever. So let's say, because let's think about like why we'd want to use inheritance in coding. Let's say we're doing like a pet app or something. We might want to have, because we might have like dogs and cats and birds. And we could go define all these classes for cats and dogs and birds, which we're going to want to do, but they're going to share a lot of the same stuff. Like dog's going to have a name and age, a bird's going to have a name and age, a cat's going to have a name and age. So what we can do is we can create kind of like this parent class where we have this similar data. For instance, like a mammal class. And we can say, hey, all mammals have a name and an age. All mammals breathe. And all mammals speak. But this one's raising an error. Let's not define the speak method and see what happens. So I have my cat extend from mammal. Oh yeah, and there's also this initialize method. So here we're calling the super method. So we're saying, hey, call the mammal initialize method. And then the mammal is going to initialize the variables at name and at age. And those are, we're having those set as getters and setters. So if I try running this, I'm going to get an error because I deleted that speak. Because I raise an error. This is how I can actually cause an error. I can throw an error right here. So what I'm saying is, I want all mammals to have a speak method. All mammals should be able to speak. But I don't really know how a mammal speaks. I just know they can speak. For instance, if I'm going to say a cat speaks, I'm going to say def speak. Cat's going to say meow. If I had a dog class, dog would say rough. But I know since they're mammals, I know they should all be able to speak. Just they're going to implement it differently. So now if I run this, here we go. Inhale and exhale and meow. And to make that a dog. Dog breathes as well, and it says rough. Does the super make sense? I'm trying to think, what does a dog have that a cat doesn't? Any ideas?
Canine teeth.
Teeth. I guess, yeah. But that's like a specific thing. I mean, that is like a toy. They all both have toys.
Digging.
Or a leash.
A leash. Okay, a dog has a leash. That's a good one. So, because maybe I want my dog to have like a leash. I don't know, leash brand. Or like a ball. Or like favorite ball. Let's just say ball type. And then like a cat might have like catnip. Favorite catnip. Favorite ball. Because what we can do with, so once just kind of going with this inheritance, I could have my, I could have a cat could have its own instance variable of like, favorite catnip. And a dog could have like their favorite ball. So the initialize method, I can set like these instance variables specific to a dog and specific to a cat here, and do the attribute accessors as well. Let's call this favorite catnip. And then this one would be like favorite ball. But then call the super method, which is the parent initialize method, which would initialize the name and age. And name is going to be visible here. Oh, now I'm getting errors because now I've added another. Now these are both expecting like 3, so dog. Let's give them like a tennis ball. Let's also put the name here. Jack's roof. You can also use the self keyword right here. Let's just log self in the function. Dog. There's the memory address. There's like the instance of the dog. Self.name. So if I use self in a instance method, it refers to this or the self. I'm going to use the this keyword. It refers to this instance of the class. Because in JavaScript, it's going to be this. So the self.name refers to this instance calling the method. Does that make sense? If I had another dog, Tony, I did, Tony.speak. the self is for that one's going to be Tony. Just put the like at memory address there. They are different. Those are very similar, but there's a 7 and 5. Those are two different memory addresses. So those are two different instances of the dog. So the self is referring, in an instance method, the self is referring to the instance of the class. But this, that is calling it. Let's look at one more example and then we'll take a break. Kind of looking at our person class again. So I'm just trying to slack this out. This is like, I'll copy this. Okay. So I'm just going to make a new file, call this like demo or something, and then paste what I threw in Slack there. So just another example, just to kind of think about how we could use inheritance again. You know, we could have class person. They have these attribute accessors, first name, last name, and school. So we initialize all of these. Then we have a greet method where we're going to raise an error. So they all have to, anything that inherits from this class has to define the greet method. We're going to see a really, really clear example when we get to React of why you want to do this. Because React, when we extend, when we're going to go to React, we're going to extend from react.component, and they're going to make us define a function or throw an error. So that happens. So sometimes you can say, hey, I'm going to make you define this function by throwing an error if whoever inherits from this class does not define it. So we can have we could have a person, and then we could have a student extend from person, and they just have a different greet method. We could have a TA extend from person, and they just, their message is different from how they greet. But they're all people. They just have different roles. And yeah, maybe a teacher, has a salary. So if there's anything else you'd want to add that maybe like the other instances or the other classes don't have, like say like a salary, then I would come in here and define my initialize method. Say like at salary equals salary, and then super, all the rest of the stuff. But then I would need to come in here and throw all this in here. Questions on this? So inheritance is pretty important. That's like when you generate your Rails model and you have like class, I don't know, whatever model item. And it extends from, active record. And that's all your class is. That's all your model file is. Well, it's that inheritance. Well, now your item class has all of these methods like item.all and item.find So you have all these methods on this item class because active record is the parent class and it's doing all of that stuff for you. And then you can come make an instance of item when you do like your new, you do like item dot new, give it your, item params method. Now you have an instance of the item class. And then you have instance method, item dot save. Now item dot errors. Those are instance methods on your model. Class methods on your model. And then item params, that's like a private method that you defined actually in your controller. Right? That'd be a private method in your items controller.
Could you scroll up?
Mhm.
Okay, it wasn't super. What was the other word you used that I didn't recognize? Are you up at the top?
The raise.
Yeah, the raise. Can you, what exactly did that mean? Is that like if it's not defined in the children, then that's what will be called?
Well, right. So let's just do example, def example. Let's say, I don't know, like I'm doing like a divide function. I forget if Ruby, you can divide by 0 in Ruby. 2 divided by 0. Okay. Yeah, that throws an error because you can't divide by 0. But this is their own like 0 division error. Let's say for whatever reason, I don't know, like I don't want you to divide by, this is like, just takes a number. And I can just raise an error. Like if num equals 1. This is not a true example, but let's just say we're taking two numbers. If num1 is 1, so num2 is 1, you can't divide by 2. And then we'll just return num1 divided by num2. So I can divide 2 and 2, but if I try to divide 2 and 1, see what happens here. Exit Ruby demo. So I just threw an error, a runtime error. I mean, I wouldn't want to do that, but I can throw errors in this app. For some reason, I have like, you can't divide by 1. And I want that to fail. Like I want that to crash. Like in JavaScript, I think JavaScript, it does a lot. Let's see what JavaScript does. If I do 1 divided by 0. Yeah, stupid. It's infinity. That might not, that's probably not like, I hate JavaScript for shit like that. Like, you probably want that to fail, right? Or you'd at least want it to return like man, not a number. Like, I don't know.
So why did you use it up at the top? What was it doing up there?
What I'm doing here is, you know, if I'm making people, if someone is inheriting from this class and they're going to call this method, I'm saying they need to the subclass needs to define it.
Okay, yeah. So if it's not defined in one of the subclasses, then when it's called in that class, it will just raise that error.
It'll throw an error.
Okay.
I
Okay, cool.
think this is a better example in the mammal class because a mammal is not, you can't have a instance of a mammal, really. A mammal is like, it's more generic, right? It's like a dog is a more specific thing. So I could say mammals just kind of like this kind of classification of my pets, which I'm gonna have like a dog. I can actually have a dog, but I don't know what a mammal looks like, right? Because mammals are so different from one another. But a mammal's a good classification of things that share a lot of the same things. Like all mammals have hair, that kind of thing. Let's just, since we're talking about the try catch, let's just finish this demo. I can, we've seen try catch in JavaScript, right? So it's very simple because what this is like we can handle errors. So in JavaScript, we say we throw an error and then we can catch an error. In Ruby, we raise an error and then we can like do a begin and then a rescue. Error. So it's the same thing, it's just different syntax. Oh, I forgot, how did I forget the syntax? Rescue error. I'm just gonna Google this really quick. Is that Garrett? How do I grab the error? That. I don't know, there's a way to grab that error, but notice how when I have the begin, when I throw that in the begin and rescue, it's not crashing my app. It should put here. Oh, I need to.
I think you may have changed your if to just up above. Yeah, you changed it to 0 instead of 1.
Oh, I did. Okay. Oh, I'll do it here. Okay, yeah, thank you. It's like, what's going on here? See if I can log that error. So this is, I can begin and then I can rescue. So I can catch that error and then not crash. You see the difference here when it's in the begin? If it's not, like my app stops right here, it crashes. Like my app is done running. So if I don't catch my error, my app doesn't get to this puts. But if I do catch it, I can then handle the error here. So maybe I don't want my app to crash if they divide by 0. I just want to say, hey, you can't divide by 0 and not have my app blow up. And that's actually what I want to do here. Because now if I try to divide by 0, my app's not going to crash. I'm going to give them this nice message, cannot divide by 0 in this app. If they try to divide by 0, then it does crash if it's not in the begin rescue. So raise and rescue, try catch. Same, it's error handling. All languages are going to have error handling, just different syntax. Cool. Yeah, let's go ahead, take a break. Let's come back at 10:55. I think we'll get into React next and talk about classes in React and JavaScript.